Hey guys, so we got introduced to coding on Wednesday, and it was a little bit difficult. So I wanted to give you guys like a more in-depth explanation and show you how I might approach this fizzbuzz problem. So just to remind ourselves, fizzbuzz, and if you can look at we can look at the Wikipedia article here. Fizzbuzz is a group word game for children to teach them about division. Players take turns to count incrementally, replacing any number divisible by 3 with the word fizz, and any number divisible by 5 with the word buzz. So when we play, players generally sit in a circle. The player designated to go first says the number 1, and each player thenceforth counts one number in turn. However, any number divisible by 3 is replaced by the word fizz. Okay, so let's just write down in English what we want our code to do. So number divisible by 3 returns fizz. Okay, first point. Okay, going back. And any number divisible by 5 gets replaced by the word buzz. So let's add that to our list. And so what we do first is we write down what we want our program to do in pseudocode, or basically just plain English. So here I would write number divisible by 5 returns buzz. Okay, going back to the game definition. So now numbers divisible by 15 should become fizzbuzz. Okay, so that's our third requirement here. Number divisible by 15 returns fizzbuzz. Okay. And a player who hesitates or makes a mistake is eliminated from the game. So for example, here's an example game. So it goes 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz, 16, 17, and so on and so forth. Okay, so let's go ahead and see how we can implement this with Python. And we're going to do it in like small bite-sized steps along the way, and eventually build up to the whole, so that we can verify whether a game is like correct or not. So I'm going to go ahead and define a test function, and I'm going to use this function to make sure that my my fizzbuzz function is working correctly. So we can go ahead and exit out of this Wikipedia. We got what we need from that. Let's go ahead and maximize this. Okay, so now we want to make sure, we want to assert that fizzbuzz for number 1, that's just going to, it's not going to return anything for us. Okay, so we want to return a blank space for fizzbuzz 1, right? And so let's just run that and see our test fail. Okay, so that passed. That's not what we want. So let's just return fizz. Alright, and we have to, in Python, we have to call our function in order to make it run. So now this is going to call fizzbuzz. It's going to go up here. It's going to say assert. It's going to call fizzbuzz with the number 1, and we're going to assert that it equals an empty string. So let's just see what happens here. We're going to click run. Okay, so we got an error. Assert, so type error. Fizzbuzz takes 0 positional arguments, but 1 was given. So a type error. So we're giving it an argument here, but in our definition we didn't give it an argument. So let's go ahead and do that. Number. Let's just call it number. So now we've given it an argument, and let's just run it and see what happens. Okay, so now we've fixed the type error, and now we have an assertion error. So that means our assertion that fizzbuzz with the number 1 is going to return an empty string. That is false. So now we've got a false test. We want to refactor our fizzbuzz code, rerun it, and check to see if our test passes. So if I give fizzbuzz the number 1, how can I make sure that it returns just an empty string? Well, the simplest way is to just return an empty string for no matter the number you give it. So let's do that. Okay, so our test passed because we didn't get anything that returned. This thing is going to scream, and it's going to throw an error at us if our code isn't working. So when we get nothing, we know that our code is working. So now what about like the number 2, the number 3, and so on? So let's add another test. So we're going to copy this, just paste that here. Oops. Okay. Now what about the number 2? We also want to return an empty string. So let's see what that's going to return when we run this. Okay, and so our test worked. So let's try another number. Okay, let's try the number 3. So we want the number 3. So we've got our rules here. We want it to return fizz. We want to assert that fizzbuzz for the number 3 is going to return fizz. So let's check and make sure that that is working. And we can, if we don't want to run a line, we can just add a pound sign in front of it, and that treats it as a comment. So it's going to skip this line. So let's see what happens when we run our code. Okay, so we've got an assertion error here. Fizzbuzz 3, this assertion is failing. So we want to make sure with our program that fizzbuzz 3 returns fizz. That's not the case with our current implementation. So let's write enough code in fizzbuzz to make this test pass for the number 3. So if we get the number 3, if number equals 3, what do we want to do? We want to return fizz. Otherwise, we want to return just an empty string. So we can just say else return an empty string. So let's just see if that is going to pass our tests. Okay, and let's just run that one more time and see that. Okay, so we did not get any errors. That means our current implementation is making all of our tests pass. So let's try another number. What about 4? For 4, we want to just have an empty string. That's not interesting. What about 5? 5, we want to get buzz. So let's run our test and see if our current implementation is going to work for multiples for the number 5. Okay, so we get an assertion error. Assert fizzbuzz 5 equals buzz. Our current implementation is not passing this test. So now let's add just enough code in order to make our test pass with this new test case, number equal 5. So elif number equals 5, we want to return buzz, else return an empty string. Okay, so let's see if that works. We're going to run our code, and we got no assertion error, so that means that our code is now working for these test cases here. So let's try another one. Let's try 6. Not 62, 6. For 6, that's going to be a multiple of 3, so we want to get fizz back. Let's see if our code is working for this test case. Okay, so we're getting an assertion error. Fizzbuzz 6 equals fizz. That is not currently working. So when we think about this, we want to get multiples of 3 returning the word fizz, not just the number 3, not just when number equals 3. When number is a multiple of 3, we want to return fizz. So how can we express that in Python code? So in class, we got introduced to the mod operator. So 6 mod 3 is going to equal 0, and 7 mod 3 is going to equal 1. And the equivalent of this in Python is, so it's the exact same concept, we just express it differently with a percent sign. So in Python, percent equals mod in Visual Basic. So whenever number modulus 3 equals 0, we want to return fizz. And so whenever this number has 0 remainder, when we divide this number by 3 and the remainder is 0, that's what this line here is saying. We want to return fizz, the string fizz. So let's see if this passes our test. Okay, so it passed our test. Now we know that for number equals 3 and number equals 6, we're going to return fizz, just like we want. So let's do some more tests here. How about let's see, how about a multiple of 5? What about 10? Is that when we get a multiple of, when we get 10, which is a multiple of 5, we also want to return buzz. So let's see what happens here. We run our code, and we see that when number equals 10, we are not getting the string buzz. That's why this assertion error is raised. So now what we want to do is change our code just enough to pass this additional test without breaking any of our previous tests. So now we've changed this first condition to use the modulus operator. Let's try and change the second condition to use the modulus operator too. So let's see if this is going to make our code work. So whenever we get, so what this code is saying in English is, whenever we get a number that is divisible by 5, return the string buzz. And another way, whenever we divide number by 5 and we have 0 remainder, give us back the string buzz. So now let's see if this passes our test cases. Okay, cool, awesome. So now our implementation of fizzbuzz is passing for all of these test cases. So now let's do something a little bit more difficult. What about 15? So this is going to be divisible by 3 and 5. So is this going to give us what we want? We want to get fizzbuzz, like we saw from the Wikipedia article. So whenever a number divisible by 15, we want to return fizzbuzz. So let's see how we can do that. So first, let's see if what is our code? Here's the question we want to answer. What is fizzbuzz going to return if we give it the number 15? So let's find out. And let's go ahead and return this, or run our function. Okay, so we've got an assertion error. Fizzbuzz 15 equals fizzbuzz. This is incorrect. This is not passing currently. So now we want to change our code just enough in order to pass this additional case where number equals 15. Okay? So now let's think about what we could do. So whenever we get, here's one implementation, and we can test and see if it works. So elif, if number is divisible by 3 and number is, okay, if it's divisible by 3, so the remainder is equal to 0, and if the remainder when you divide it by 5 is also equal to 0, we want to get back the string fizzbuzz, else give us back an empty string. So take a second, pause the video, and go ahead and figure out what is this going to return. When we run this code, when we run this code here, are we going to get the string fizzbuzz back? So go ahead and stop and figure that out for yourselves, and then continue on. Alright, so we're going to go ahead and run the code. Okay, so we got an assertion error. Our code is not currently working whenever number is 15. We do not get back fizzbuzz, which is why we get this assertion error that's raised. Okay, so now we got to refactor our code in order to make it work with this new case for when number is equal to 15. So, let's see what happens. Let's say number is 15, and let's walk through our code and see what happens here. So number, it goes to this: 15 modulus 3 equals 0, right? So because 3 times 5 equals 15, so there's 0 remainder when we divide 15 by 3. And so when we enter 15 into this code, this condition is going to return true, and we're going to get back fizz. And we can convince ourselves of that by running our current implementation, fizzbuzz, with the number 15. Let's go ahead and run that and just confirm that this actually equals fizz. So let's print. We want to print this. Run. Okay, so we're getting back fizz. So we see the problem here. When number equals 15, it doesn't get down to this condition here. So we're not getting back fizzbuzz. It returns, this condition here returns true, and we're getting fizz. So now we need to update our code so that when number equals 15, it hits this condition right here. I'm going to go ahead and comment that out. Comment this back in. So now we're going to refactor our code. And so what we can do is we can pull this up to the top. So this is the first thing, the first condition that gets checked. So we can just copy this, remove that, and add it here. And we want to make this fizzbuzz. We want this to equal fizz. So we just exchanged positions for these two conditions. And so when number is divisible by 3 and divisible by 5, we want to return fizzbuzz. Else if number is divisible by 5, we want to return by buzz. So what this means is only one of these conditions is going to be met. It's not going to return true for this condition and return true for this condition. Okay, so now the question is, did this refactor that we did with our fizzbuzz implementation, will it result in our tests all passing? So go ahead and take a second and come up with an answer. All right, now we're going to run our code. And we did not get any assertion errors, which means our current implementation is passing. So now we've done what we set out to do, right? Our original goals were to write a fizzbuzz function that returns fizz when a number is divisible by 3, buzz when a number is divisible by 5, and fizzbuzz when a number is divisible by 15. In order to convince yourself of this, you can go ahead and write a little, you can actually print out the results, and we'll do that by making a new function called print result. So what we want to do is we want to give, for this function print result, we want to print out numbers 0 to 20 along with fizzbuzz. So okay, so there's a better way that we can say this. So for numbers between 0 and 20, we want to print out the number and fizzbuzz of the number, so that we can make sure that our function is giving us the result that we want. So this is our function in pseudocode here, and just delete that so it doesn't confuse anybody. So now we're going to take our pseudocode and write this in Python code. So we're going to make a for loop in Python, which we do this way, for number, and let's use a different variable just so we don't confuse ourselves with this variable. So for index in range 20, so what this does is it's going to make index go from 0, it's going to go 0, 1, 2, all the way up to 19, but it will not equal 20. I believe it won't equal 20. We'll run the function and see afterwards. So for index in 0, 1, 2, and so on, we want to print out index, do a little space, and we want to print out fizzbuzz of index. And so the idea is we're going to print out something that looks similar to this. So let's go ahead and run this just to confirm that we're getting the results we want. So we're going to run our test 2, and we're going to run print result, and let's see what we get. Okay, so already I'm seeing something wrong with our code. When we get 0, we don't want to print fizzbuzz. We want just a blank line for 0. So that's one thing to note. We do see that 3 we get fizz, which is correct. For 5 we get buzz, which is correct. 6 we get fizz, that's correct, divisible by 3. 9 divisible by 3, so we get fizz. 10 is divisible by 5, so we get buzz. 12 divisible by 3, so we get fizz. 15 divisible by fizzbuzz, or 15 divisible by 15, so we get fizz and buzz. And 18 divisible by 3, so we get fizz. So everything's working except for 0. So now we have another test case that we want to add. So, oops, okay. So, when number is 0, we want to get a blank. We want to get an empty string. We don't want to get fizzbuzz. So we have the new test. So now we want to run. We don't want to run the print result. We want to run the test, see that the test is failing because we have this new test, this new condition. So we want to make sure that our test fails. So let's run that. Okay, so we got a failure as we expected because right now fizzbuzz of 0 is returning fizzbuzz, like the string fizzbuzz. So now we want to make it return the empty string, not fizzbuzz. So let's see how we can refactor our code, change our code so that we write just enough code that it will pass all of our test cases here. Alright, so what can we do? So if number equals 0, let's go ahead and walk through the code. If 0 modulus 3 equals 0, that's true. There's no remainder when 0 is divided by 3, and when 0 is divided by 5, there's no remainder. So this condition is true, and we return fizzbuzz. That's what is currently happening. So we need to change that behavior. So we can do that by making this an else if, and if number equals 0, we want to return just the empty string. And let's see if that makes our code pass all the tests. Okay, yeah, and if you didn't see that, you didn't catch that, we ran the code, and we did not get any assertion errors. That means that now our code is working correctly when number is 0. Now let's go ahead and print out our result just to get one more sanity check. So let's go ahead and run that. And as we can see, we removed that fizzbuzz when number is equal to 0, and we kept our previous results. So now we've got a test that is passing. We've written a function, fizzbuzz, that passes for all of these tests. That we can be assured of. And so that's an example of test-driven development. And I encourage you guys to use this approach when just get familiar with this approach, and once you get a lot better, you can decide whether you want to keep using it or not. But it's good to use in the beginning because it forces you to break down a big goal you have here. We had 3 different things we wanted to do. It forces you to consider one at a time, and that's really powerful. So go ahead and let me know if you like this type of video. If you do, I'll continue making them. If not, no problem. Alright, you guys, I will see you during the next day of class.